So, hi, my name is Simon Škilić and I will present you robust question answering over the web of linked data. The thing is, the information, the structured information in the web of linked data is getting bigger and bigger, and also some question answering system uses information. Yeah, also the BART. Imagine the BART is a question answering system, and he has the question in his head, and he wants to use the structured data, something like Yago or Wikipedia, to answer these questions. Yeah, but the big problem, Tobias has already described this problem. Describe, whatever. Yeah, I will describe it again. Yeah, BART has to convert their questions to queries on structured data, and yeah, also the other question system have the same problem, which is structured data. In this paper, in this presentation, I will present you. You and BART will meet an approach to improve the robustness of question answering system, which work with structured data. Yeah. The presentation contains 4 parts. At first, we will speak about the problems, then the approach to solve these problems, and we will see then in detail how we can realize this approach. And at last, we will also see how well the approach works. Yeah. Here we see the real question, the real example of the problem. For example, who dated Lisa Simpson? And below we see the corresponding structured query. This structured query is in Sparkle query language. The Sparkle query language is an RDF query language able to retrieve and manipulate data stored in resource description framework, RDF format. And it looks like that. Yeah. We have many triples which describe the facts over the entity we are searching for. For example, yeah, we are searching for person who dated Y. Y is the character, and this character appears in Simpsons. And it's always subject, predicate, objects. So to create such triples and such query, we need to extract the information from the natural language questions. At first, we have to extract the subjects, predicates, and objects and such things. We need also the information about in which relations these words are to each other. Which words should come to the same triple. Yeah, and this is the first approach. The first approach is to make as many queries as possible. If we just check all queries, the probability is high that we find the best one. And how we do this? In general, we do just extract all phrases, possible components of sport triples, what I have already said, extract information about the relationship between the phrases, and then we create all possible sport triples and choose the best combination of them. They're doing this by creating by designing of ELP, integer linear program. I will later show a little bit, so in general, how it looks like. The second approach is to extend the query and to relax this query. Why should we do this? Why should we extend the query with textual information? For example, female smart cartoon character. This problem is that this entity is too specific. Actually, in this form, it doesn't exist in structured data. So it doesn't exist such entity or class like female smart cartoon character, but it exists a class named character. So we must search in this class, but the words like female smart, this information like female smart and cartoon is still very important for us to find the needed entity what we are searching for. Yeah. And then we just add these words like keywords and extend our Sparkle query. Like you can see the example. So realization. Realization consists of 4 parts. At first, information extraction. We'll extract all candidate phrases, then dependencies between them, and also we extract all names from structured data, all names of classes and entities and relations and so on, to which we will then map. Yeah. The second part is actually the mapping, and this is this part where we generate all possible queries and choose the best one. And then at the end of this part we will have just one query which we will extend in third part, and at last we get a list of results, and that we must have to rank. So the first part, information extraction. I called it candidate extractor. Actually, it is, there are many tools like PostDagger, Reverb-like system, and large dictionary of surface forms. So in general, it gives us just all candidates and candidates like for possible entities, classes, and relationship. Then, if we have the relationship, Stanford dependency parser gives us the arguments for the relations, like relations which objects belongs to this relation, to buy the triples. And also, it's important to determine a question type, because, for example, who gives us the information that we are searching for a person. Here's an example of candidate extractor. We just extract all possible phrases from the sentence "Who dated character appearing in The Simpsons." The candidates can also overlap, like here, appearing in and appearing. So this way we get a set pair of possible candidates. Then Stanford dependency parser gives us the relations. Who dated Lisa Simpsons? Dated is a relation. Who is first object? Lisa Simpson is the second object. And this way we get a set of all possible phrase dependencies. Then there are some special cases by Stanford dependency parser. It can be that a noun describe to the same time noun and relation, subject and the relation, like here, film by. It's actually, it's film by is something like relation directed, and also it must be also the object, one of the objects. Also, we have such cases where we didn't know which relation are there. For example, German athlete. We didn't know if this athlete was born in German or lived in German or something else in German. But we know the relation is there. So we just replace it with an variable. At the end of extraction, we have 3 sets. The first set of possible overlapping candidates. Second set is the set of semantic target candidates, and the last set is the set of these dependencies. And what we want to get, we want to get some set of P, so some subset of P. With this subset we map to the S, so to the real entities and classes which are in structured data, and we search for some set of triples. From this triple we will create our query. And at this point they design actually an ELP problem to check all combination. But I will just in general describe the idea. So in general they make these 3 steps until they find the best query. So they generate possible templates for set of spot triples. This one, possible set. Then they choose possible mappings to the semantic candidates, evaluate the mappings, and repeat this until they find best query. Here's the first step. They just assign the elements from P to. They create some possible set and assign the element from P to this set. In the second step, we have something like that. We have already some triples, spot triples, and now we need the really existing classes and entities and so on. So they do here mapping. And at the end, they should, of course, be able to evaluate this query, and their importance following criteria. First, how good are mappings for each class entity by itself, independent of other mappings? Then, how strongly related are entities of the mappings? That means actually how strong related all entities and maybe classes too, which are in the same query. Like, for example, in one triple can be Bart, in the other triple can be Huma, and how related these entities to each other. They can also be in the same triple. It's not important. So it's also important how many phrase dependencies which we get it from Stanford dependency parser are still there. How many are still existing? And how many triples have non-empty answers? They really do ask structured data with each triple. They build from each triple and query and ask the system and look if they get empty lists or not. So after that we have such set of triples like person, dated characters, person, dated character appears in Simpsons, and now we actually create the query just by substitution of classes by variables, with variables. Here we substitute person with x, then character with y, and also we add further triples like which define the variables, which here x and y, x type person, y type character. This information, which class it was, we cannot lose it. So then we have finished query, and now we can relax and extend this query. That was the second approach what they have introduced. There are 3 technique. The first one, text extension. We just take all phrases, all words which are not which weren't mapped, and take it to the textual extension. Like here, who appears in Simpsons as a primary school teacher? X-type person, X appears in Simpsons, and the information primary school teacher wasn't anywhere mapped, anywhere used, so it will be used as textual extension here. The second technique is the empty result relaxation. So it can be that after we have got the finished query, with this query leads us to empty list result. And what does it mean? It means that the query could be too specific, can be too specific, or it can also be that each triple gives us some result, but together the intersection of them is 0. It's empty list. So in this case we do the relaxation. We relax the query. By this algorithm we take just the first triple, and the next one iteratively add triples to the query while the entire query gets result. And at this point where we get no result with this triple, then we know this triple is bad, but we don't remove this query, we just add this query as a textual extension. Here's the example. For example, this query leads us to empty list result list. X-type person, X appears in Simpsons, but X worked as primary school teacher. This triple will lead us to empty list result. So we remove it and add as textual information. So, and now the last technique, extreme relaxation. Actually, this is the same technique like the second one. This is extreme case of second technique. If we do this algorithm further and further, and we have just one triple at top, then it will happen that we have added all other words as textual extension. And here we just have type triple, and the rest is as keywords. And now we have our result, and we have to rank our results. Here's an example. For query X-type character, Y-type president, X appears with Y, you will get something like Huma. Because Huma is character, Obama is the president, and Huma appeared with Obama. In some cases, don't know. Can be. And also cartoon was matched. So, how we calculate the score for Huma? The score for Huma will be calculated by using the importance of the matched entities. In this case, Huma and Obama. We have find it Huma because he appears with Obama, and Obama is the president, and it's matter how important these words are for ranking. What means importance? Importance means how many links linked to these entities in Wikipedia. It's also important the keywords. For example, it's important for Huma. It's matter for Huma in which relation or how typical cartoon für Huma to be cartoon. So this keyword. For example, if cartoon, cartoon is actually very important maybe for Huma. So evaluation. They For evaluation, they use Wikipedia and Yago, which contains hundreds, millions of triples. These triples are linked to Wikipedia articles, and from these articles they take their textual description. Yago also provides a huge set of name, entity, and phrase entity pairs, what gives us the basis for mappings from phrases to semantic targets. Actually, this is a collection of paraphrases and surfaces to improve the mapping. And from PATI, they take the collection, also surface collection for relations to improve the mapping from the relations of the relations. Yeah, as test data, they used Qual2, the second workshop on question answering over linked data. They took just 19 factoid questions and 13 list questions. Also, they have experimented with some telegraphic queries. Telegraphic queries, this is something like, I have an example here, something like bands covering songs by Stones, female smart cartoon characters. Actually, this is such questions how we do which we use by asking Google or which we use for searching in Google. Not really questions. Yeah. And to measure, we use these three methods: mean, reciprocal rank for factoid questions, and mean average precision, and normalized discounted cumulative gain for list questions. Yeah, if someone doesn't know what that is, I can explain it later. They had these test cases. Spox plus relax, this is actually a mapping plus relaxation and extension all together. Then just mapping, mapping and relaxation without textual extension. And at last they have also tested such queries where they just, all queries have this form after extreme relaxation. So, and there are the results. Yeah, how we can see, Spox plus relax is the best approach. For Adam. Most of all, yeah. Most of all for NDCG and map measure methods, because by these methods, the ranking of elements is meta. So we can, this means that the textual extension gives us the best ranking. So the better hits go upstairs and will be at top. Spore plus relax and spore have similar results. So it's because relaxation is obviously limited by removing of textual extension, and the query words plus type is the worst approach. How we can see the same thing is for the factoid questions. Yeah. Yeah. They have also compared their system against other system from Qual2 workshop, SAMSEC, MHE, and Quarkis. And the problem was that this system were not really comparable to Spock's Bruce Relax because they have not so many answers. The result lists are not so big, so they introduced cut-offs. They make cut-offs over their own results. Here we can see they took just first ones and top 10s and top 100 and so on. And by list questions, Spock's outperforms the other systems. We can see it. We can also see that Spock's by big lists, for the big list, the recall is really good. But by factoid questions, SAMSEC was better as Spock's approach. The main reason for that is bad estimation of the answer types. For example, who developed Skype? Right answer will be Skype Technologies. But Spock's would create this query where type is person, and of course Skype Technology is not a person. So they get an empty list. They would get an empty list. They have experimented also with telegraphic queries, but they get similar results to the paper which they describe, and also the problem was that in this paper they have used an older version of Yago, and it was not really comparable. Also, they had not really they describe bad which questions they have used and so on. So it was not really comparable. Conclusion: it works. They have shown that textual extension of queries can lead to better answers for a wide range of natural language queries. Thank you for your attention.
Thank you. Questions?
Yeah?
In which sense is this method robust?
For what?
Robust, yeah.
It's method for bust?
In which sense is it robust?
Can you ask me in other words? What do you mean with robust?
It's in the title of the robust question.
Robust.
Robust. Oh, sorry. It's in which why it's robust? You mean? Because they make many possibilities of the query. They create many possibilities, and they have a good objective function. And this is the place where this translation is a place where we can make many errors. And they make this translation, conversion from natural language to Sparkle query more robust with by creating many possibilities and choosing the best one. Also, textual extension. I don't know if that makes the system more robust, but it of course improves the results.
So, what is the text for each entity? Is it the Wikipedia page? I mean,
the text?
They use Sparkle on DBpedia, or what was it?
I don't really know. I'm actually not sure, but I think they take some keywords. They extract just some keywords. For example, some information right at the side, description, and then the categories and so on, such informations.
So I have two questions. The first isn't really for you, but it's something that occurred to me while you were talking, and maybe anyone knows the answer. It has to do with this question word thing, which is that Well, the usage of who developed Skype is interesting because we're talking about Skype in a person-like way. Here's my question. Other languages that don't have question pronouns that betray class information about the object. In other words, I know that I think some Asian languages just have a question participle at the end of the sentence, like developed Skype technologies, question mark, more or less. And does anyone know anything about these languages and what strategies could be used against them? Or does this even exist? I don't know. I'm not a language person.
Is this a question for me or for?
No, anyone. I know the answer, that's for you. Okay, this one is more pertinent to your presentation, and you talked about this intersection of the intersection of triples, and then we throw on away the intersection of zero.
The intersection of result list which we get with these triples.
Okay, that seems incredibly order dependent, because if I intersect A with B, then I get a zero intersection, I throw away B, but if I had done them in the opposite order, then I would have thrown away A.
Yes.
Wenn ich eine andere Reihenfolge hatte, dann würde ich
Ja, das ist ja so. Wenn du eine Reihenfolge hättest. Yeah, I don't really know how they do the intersection of this list. I just said the intersection, or I don't think. You mean okay? You mean the ordering of the triples. It was, I think, yeah. For example, here. If the ordering matters.
Well, it does if we're going to throw the second one away, or we're going to change it dramatically. Then it definitely matters.
I think it's not really the
for
ordering.
relaxation.
Huh?
He means for relaxation.
For relaxation. Yeah. For example, yeah, I didn't say it. I didn't say it. Where was the relaxation? Yeah, the second technique. Yeah. If we relaxate this triple, we add this triple to this triple where the variable which was used by bad triple is defined. In this case, by type person. Was this the question?
No.
At which triple the extension?
My question is if there's
At first they take a type person, a type triple, which defines which entities we are searching for. Because if they relax this triple, of course they will not get some results and so on.
Yeah, I think the point is if you have like two triples and the intersection gives you an empty result.
Yeah.
Then you can relax the first triple or you can relax the second.
Yeah, and the ordering matters, because if we relax the first one, then when we are searching for person, for example, and if we relax this triple, then we would not find some persons. But for example, primary school teachers, what was not the questions? War nicht die Frage. Yeah.
So if you go to the next slide, no, the one where the mapping was shown between triples and classes, I think. Yeah, this one. So they formulate this as an ILP, I think you said.
Yeah.
And so what is the objective function then? They try to maximize somehow this.
Actually, this is the objective function. Yeah, I have just extracted the information as the goals of this objective function. I cannot really remember how the formula was.
So they have scores somehow for each of these points, and then they
They have scores for classes, for entities, by separately. Then they have scores for entities and for groups of entities, how they are related and so on.
Okay, and then they just somehow try all combinations basically to get the maximum.
And okay, of course, they have also many constraints and so on to make the combination number smaller and so on.
More questions? Okay, thank you again.